Space looks peaceful from down here. A calm black sky, tiny stars, a big quiet moon, maybe a spaceship floating gently while someone plays dramatic music. Very beautiful, very mysterious, very good poster material, but real space is not peaceful. Real space is a freezing, airless, radioactive emptiness full of invisible danger, flying rocks, exploding stars, and distances so huge that your brain basically gives up and says, let's just call it far. Movies make space scary with aliens, laser battles, and dramatic countdowns. But real space is scarier for one simple reason. It does not hate you. It does not chase you. It does not even notice you. It just follows physics. And physics has no customer service department. Let's start with the most obvious problem. There is no air. On Earth, we walk around inside a protective bubble called the atmosphere. It gives us oxygen, pressure, warmth, weather, and something to dramatically inhale when we hear bad news. In space, none of that exists. If a human suddenly appeared in space without a suit, they would not instantly explode like some movies suggest, but it would still be extremely bad. The air in your lungs would expand. Water on exposed surfaces, like your tongue and eyes, could start to boil because the pressure is so low. You would lose consciousness quickly because there is no oxygen. And after that, you would just drift there while the universe continues being very large and very unimpressed. No monster, no villain speech. Just a terrible meeting with basic chemistry. Next, temperature. People say space is cold, and yes, it can be extremely cold. But space temperature is weird because there is almost no air or matter to carry heat away. If you are in direct sunlight, you can get extremely hot. If you are in shadow, you can get extremely cold. So a spacecraft has to handle both roasting and freezing. At the same time, imagine one side of your body is being toasted by the sun, and the other side is being stored in a cosmic freezer. Now remove the air, comfort, and the ability to complain to anyone nearby. That is space. Then there is radiation. Earth protects us with its atmosphere and magnetic field. These act like invisible shields, blocking or reducing a lot of dangerous radiation from the sun and deep space. Space does not give you those shields. Astronauts have to worry about cosmic rays and solar particles that can damage cells and DNA. And the sun, our friendly neighborhood light bulb, sometimes has storms. A solar storm can throw huge clouds of charged particles into space. From Earth, this can create beautiful auroras. In space, it can be dangerous. Basically, the sun occasionally sneezes radioactive electricity. Very pretty from a distance, less charming if you are inside a metal can between planets. Now let's talk about tiny rocks. Space looks empty, but it is not completely empty. There are small pieces of rock, dust, ice, and human-made debris flying around at ridiculous speeds. In orbit, even something tiny can hit with huge energy. A paint fleck can damage equipment. A small piece of debris can punch a hole in a spacecraft. A larger object can ruin the whole mission. On Earth, a grain of sand is annoying in your shoe. In space, a grain of sand can become a high-speed insult from the void. This is why spacecraft and space stations need shielding, tracking systems, and careful planning. Because space does not need a giant asteroid to be dangerous. Sometimes it just needs a very committed pebble. Now, black holes. Movies love black holes. They look amazing. A dark circle, swirling light, music that sounds like the universe is thinking. But black holes are not giant vacuum cleaners randomly sucking up everything. If the sun somehow became a black hole with the same mass, Earth would keep orbiting it. We would freeze because there would be no sunlight, which is a separate disaster, but we would not instantly get pulled in. The real danger of a black hole is getting too close. Gravity near a black hole can become so extreme that the pull on one part of your body is much stronger than the pull on another part. This can stretch objects into long, thin shapes. Scientists call this spaghettification, which is an absurdly silly word for one of the worst possible experiences. Imagine your feet are pulled harder than your head, then much harder. Then congratulations, you are pasta. Thank you, science, for naming cosmic horror like a dinner special. And black holes are not even the only terrifying dead star objects. There are neutron stars. A neutron star can form after a massive star explodes. It is incredibly dense. A teaspoon of neutron star material would weigh billions of tons. Some neutron stars spin many times per second and shoot beams of radiation into space like cosmic lighthouses. They are called pulsars. From far away, they are fascinating. Up close, they are a very strong suggestion to leave. A neutron star is basically a city-sized object with the mass of a star and the personality of a blender made of gravity. Now let's talk about star explosions. A supernova happens when certain stars die in a massive explosion. For a while, a supernova can shine brighter than an entire galaxy. That sounds beautiful, and it is. Supernovas help spread heavy elements into space. The atoms that make planets, oceans, rocks, and even parts of your body were created in stars and scattered by cosmic events. So, in a way, we owe our existence to ancient star explosions, which is poetic. Also, those are star explosions. If a supernova happened close enough to Earth, it could damage the ozone layer and affect life on the planet. Luckily, dangerous nearby supernovas are rare. But the fact that nearby exploding star is something science can even discuss is unsettling. Then there are gamma ray bursts. These are among the most powerful explosions in the universe. They can happen when massive stars collapse or when neutron stars collide. They release intense beams of gamma radiation. If one happened close enough and pointed directly at Earth, it could seriously damage our atmosphere. The chances of this happening to us are extremely low, but the concept is still horrifying. Somewhere in the universe, a star can die so violently that it fires a cosmic death flashlight. And if the flashlight points at you, that is a bad day for everyone. Now imagine a planet with no star. These are rogue planets. Most planets orbit stars, but some get kicked out of their solar systems by gravity. Then they drift through the galaxy alone. No sunrise, no sunset, no warm star in the sky, just darkness. A rogue planet is basically a frozen world wandering through space like it missed the bus 5 billion years ago. Could one pass through our solar system and disturb orbits? In theory, yes. Is it likely anytime soon? No. But emotionally, the idea is deeply rude. Space also messes with time. According to relativity, time does not pass at exactly the same rate everywhere. Gravity and speed can affect time. Near something extremely massive, like a black hole, time can pass differently compared to far away. This is real physics, not just science fiction. So, the universe is not only huge, dark, radioactive, and full of flying rocks, it also refuses to run on one simple clock. Very inconsiderate. And finally, the biggest fear of all, the size. Space is so unbelievably large that normal words stop working. The moon is about 384,000 kilometers away. That already sounds far. Mars can be tens or hundreds of millions of kilometers away. The nearest star system is more than 4 light years away. A light year is the distance light travels in 1 year. Light is extremely fast. So when something is 4 light years away, that means even light needs more than 4 years to get there. And that is just the nearest star system. The rest of the universe is so big that far away becomes a joke. If something goes wrong in deep space, help is not nearby. There is no pulling over, no fresh air, no emergency exit, no quick rescue. There is just a tiny spacecraft, surrounded by endless distance, hoping every machine keeps working. So yes, space is beautiful. It gave us stars, planets, galaxies, and the atoms in our bodies. But it is also full of vacuum, radiation, extreme temperatures, high-speed debris, black holes, neutron stars, supernovas, gamma ray bursts, lonely planets, broken time, and distances so big they make your brain want to lie down. Movies make space scary with monsters. Real space is scarier because it does not need monsters. It has physics, and physics is extremely committed.